Okay, this is chapter 2, measurement. We're going to talk about types of measurement, metric system, and temperature conversions. So qualitative measurements are descriptive. So you would use, like you would say, a brown table. Quantitative are measurements that are measured. So they must include a unit. So you would say a 6-meter table. So qualitative gives a descriptive term, quantitative gives a number with the unit. In the metric system, or the Systems International, that's the system we will use in chemistry, you have what we call base units. These are a defined measurement unit that is based on an object or an event in the physical world. There are 7 base units. I've only listed 5 for us. Next to the name of unit, you might want to add the word base or standard unit. For length, it is the meter. The symbol is lowercase m. Mass is the kilogram, kg. Temperature is Kelvin, capital K. Amount of a substance is a mole, M-O-L. And time is a second, which is a S. Now, there are other units like volume and density. We call them derived units because they come from some form of these. Whenever we have a unit, we will put a prefix in the front to determine the range of measurement. So I've given you some prefixes. We will talk more about these later, but capital M is mega. That would be like you have a million. So M, capital M, lowercase m would be megameter. You'd have 1,000,000 meters on down to nano, which is the smallest. Okay, let's talk a little bit about the base units. So we have mass, which is the amount of matter in an object. It's always the same regardless of position. So that means you have the same mass whether you're here on the surface of the earth or on the moon. You measure it with a balance. The standard unit is the kilogram, although gram is more commonly used. So in lab, you'd measure things in grams, not kilograms. People interchange mass and weight on the surface of the earth. They're the same, but weight is actually the measure of Earth's gravitational attraction for an object. It varies with the distance from the earth. The further away you are from the surface of the earth, the less gravity pulls on you. Length is measured with the ruler. The standard unit is a meter. Temperature is a quantitative measure of the average kinetic energy of molecules in matter. The faster the molecules are moving, the higher the temp. We commonly think of temp as how hot or cold something is, but that is actually qualitative. The instrument is the thermometer. The SI unit is Kelvin, or capital K, and we also use Celsius. So I'm going to give you some formulas. So if you have degrees Celsius, it's equal to degree Fahrenheit minus 32, put that in parentheses, divided by 1.8. If you want Fahrenheit, you can manipulate this formula, so it's going to be Fahrenheit is equal to degrees Celsius times 1.8. And then you are going to add 32. And then if you want Kelvin, Kelvin is equal to Celsius plus 273. Now, if you want Celsius, you would say Celsius, and you know Kelvin, you'd say Celsius is equal to Kelvin minus 273. So we're going to work these problems. So what is Fahrenheit? If the temperature, that should say if the temperature is 87, so we choose our formula. So we know we have 87, we want to find Fahrenheit, so we're going to use this formula. So you write your formula. Fahrenheit is equal to degrees Celsius times 1.8 plus 32 is equal to 87 Celsius times 1.8 plus 32. Put it in your calculator. I'm using the TI-30XA. Make sure it's cleared. So you say 87 times 1.8. I always hit equal because of order of operation, and then add 32. So your answer is 188.6 degrees Fahrenheit. Put a box around your answer. Make sure you show your formula, make sure you show your work, and then your answer to the correct number of sig figs. You don't know sig figs yet, but you have to have your formula and your work. Okay, we know Fahrenheit, we want to find Celsius, so we're going to use this formula because we know Fahrenheit and we want to find this. So you're going to write your formula, so you're going to say degrees Celsius is equal to degree Fahrenheit minus 32. Divide that by 1.8, that's your formula. Put your work in, 65 degrees Fahrenheit minus 32 in parentheses, divide by 1.8 equals, clear your calculator. So you say 65 minus 32 equals, divide by 1.8 equals. So it would be 18.33 degrees Celsius. Last one, we want to find Celsius and, we have Celsius and we want to find Kelvin. So we know Celsius and we want to find Kelvin, so we're going to use this formula. So your formula is Kelvin is equal to degrees Celsius plus 273. Now you show your work, so 46 Celsius plus 273 is equal to 319 Kelvin. That is it for temperature conversions. Okay. Volume is derived from length. It is the amount of space occupied by an object. The most commonly used unit is the liter, which is the volume of a cube that is 10 centimeters times 10 centimeters times 10 centimeters. 10 times 10 times 10 gives you 1,000 centimeters times centimeters times centimeters, centimeters cubed. 1 liter, we just said, is equal to 1,000 centimeters cubed. Our beakers in the lab are measured in milliliters, so they say 1,000 mils. So if you have 1,000 centimeters cubed equals 1,000 mils, these two are equal, so we could say 1 centimeter cubed is equal to 1 mil. So like if you had something on your homework that said 75 mils is how many centimeters cubed, well 75 mils would equal to 75 centimeters cubed. Or you could say 83 centimeters cubed is the same as 83 milliliters. In lab, we use the graduated cylinder to measure our volume. If we're doing acid-base titration, we'd use a burette. It's the most precise. Density is another derived unit. It's derived from mass and volume. We commonly say how heavy or light something is, and we will work some density problems at the end of the chapter. So this will get you through your Chapter 2, Set 1 homework. Thank you.